everyone! Today, we will take you to see how to create a reel, a calculator with real interaction. And we'll finally add this calculator to our asset library so that we can make some real instruments. And they have a screen display. Let's first take a look at the effect of this calculator. This calculator is a very simple calculator. We have some buttons, including a switch. We can use it by, we first need to click on the entire preview interface and not an editing interface. We can see the effect. Click it, and it's on. Then we can do simple calculations. 8 plus 3. And it equals 11. Well, this calculator has the logic of a real calculator. In the mounting glasses, how to implement this logic and finally add it to the asset library and turn it into a device asset that we already have. Our asset library as a device asset. Let's use this as an example to show you how to do it. Let's double-click. Let's first take a look at the model of this calculator. This model we used to create it. Finally, we import the GLB model into our sandbox. After importing it, we can simply take a look. It is divided into a screen. There will be a material for the display screen. And then we have some buttons. Of course, we made some errors here, such as 8 divided by 0 will show errors. We made a separate one. Of course, you can also display it. These buttons. There are some different buttons. So first, we hope to achieve the effect of this button. When I press it, it goes down. We don't need to do 2 opens for this effect, but directly in our model, we can achieve it through interaction. Let's look at one of the buttons. We click on the interaction. We can see that it has 3 interaction events. The first interaction event is that I want to press. The effect of pressing the button to the 2 open events. We pass the name clear as the interaction. Of course, we don't necessarily need to use this interaction. We can also directly in. Listen to the button events in the secondary development. Of course, using interactions may be more intuitive. We are using interaction here. And the second one is when we press when we click the button. We move the position of our components down a little bit. And then you can see these 2. Our interaction seems to be simultaneous with the last one, because it needs to be sent to TK and operates to change its position. Then change its position. After pressing it down, it needs to bounce back by itself, right? Here is an additional interaction. Let it after we press it. Follow the previous interaction and bounce it up. Then this function is completed. We are. We just need to copy this interaction for each. The interaction for each key. We can achieve the effect that after we click it, it can have a press down effect. Okay, after we have the button, how can we realize that when I press this thing to show on my screen? This is a very important part of this lesson. This requires us to use our to open. We click on this model, and we can see that we selected the calculator. There is a two-way switch code on it. Okay, let's go to the code. Let's go to the code. Let's click to open it. Okay, let's take a look at this code. The core of this code is to implement two parts. The first part is the real addition, subtraction, multiplication, and division. Of course, the logic of real addition, subtraction, multiplication. But if we encounter some more complex devices, it may involve more complex such interaction logic. For example, we may have our electric meter. Which wires it might involve? Which wire is connected to which wire? And what different logic will be displayed in the end? This requires you to use our two-way code to implement it. What we are demonstrating here is the basic implementation of a computer. That is, we added the button before. If it's addition, we use addition and subtraction. This is a very simple, such as synchronous logic. The more complex part is how I will display the result of this logic on my screen. We need to use the two open source codes. Off-screen function. First, when we initialize, we need to create an off-screen canvas. This canvas will not be displayed on the screen, but it is a standard. On the web, we can use the context of our canvas to draw various contents, such as drawings, to draw text, or draw some pots, or draw some circles, and so on. In fact, everything we can achieve on the web can be implemented in our code. Here I need to draw text. Of course, because this word here is a special font. So we use this LCD font. We directly process it. Of course, this LCD is built in our eyes. By default, you can use the system fonts because our computer has a special case. So we need to use LCD. After we initialize the canvas, we can call it later. Here we can. We directly use it as a private property. Secondly, we need to get this canvas. The material of the screen. Because after the canvas is drawn, I need to set it to the screen. Let's see where the material of the screen is. There is a display on our screen. We enter the display. This style. And we can see that it has basic colors. In the end, we actually set this canvas to this texture. Then it will be displayed. Okay, let's see how to set it up. We have a draw screen method here. First, we need to draw. We draw the entire result on our canvas. We set the font and color and alignment and so on. Finally, we will draw such a piece of our text. Finally, we converted the drawn the canvas into a blob. And then after getting the blob, we create a URL. Set the URL to the options of the screen materials we previously obtained. This option is the albedo texture. As for how to get this arbitrary texture, in our other two tutorials, we actually talked about it in our other tutorials. That is, we can right-click here. Left-click on the 3 dots. And then get the call code example. We can see how to set it. And then, where can we get this green canvas material? Where can we get this green canvas material? We can use our building kit. Children, to get the screen piece. This screen piece is calculated by piece. Because we are currently, which is hanging on the top layer. Hanging on the calculator, we can continuously get children and compare their names to get the material. After getting the material, set its options. We can replace the font. Well, through this secondary development code, we've realized the button and the entire the logic of the calculator to achieve real-time calculation. Let's take a look again how to install our model into our asset library. We just need to put this model, all our interactions, including our secondary development, must be attached to this, or its sub-elements. It can't be outside. If it's outside, we'll, just put. It will be lost when we put it in the asset library. We must place our secondary development, the root directory and below of this element. To place our secondary development code and interactions, In addition, if our interaction, such as an interaction here, if it controls other elements outside, it will also be lost. It can only control itself. Or this, our entire entry into the asset, the model of the asset library. Right-click on it and add it to the asset library. OK. We select an asset directory. Select all and then click OK. OK. Like this. We went back to our asset library. We can see that there is a calculator. We have already added a calculator before. Let's put it again. What? And put it again. Okay, this calculator. Sometimes the cover may not be recognized very well. You can change the cover yourself. I won't change it here. After having this calculator, in other projects, we can create a new project here. We can create a new project. After the creation is successful, we can put this. We can make the calculator an asset and put it in our entire project. In this way, in other projects in the future, we need to use the same device in other projects. And we hope that this device has its own behavior. We can reuse it in this way. Let's click on this model and find the asset library and find the calculator. We click it, and it will be added to the entire screen. Let's take a look at this. Does the calculator have all the interactions we just wrote? We click Exit, and then click 9 times 6 equals. It's 54. This is because there was a bit of a delay just now. You can see that the entire calculator, the logic has been implemented. Okay, today's class is to teach you how to our calculator with its own logic and screen. Device into our asset library and reuse it in the future. Okay, thank you all.